Welcome back. So let's move on. The most important thing that I want you to understand is what I said about the difference between an API and a query language. SQL is a query language. Spark SQL is a query language. PySpark is an API. It's in Python, and it's an API to Spark. If you use data frames transformations, that's also an API in Python. Who gets this difference between a language and an API? Who doesn't? Okay, let me explain again. So basically, the intuition is that Python has existed for a very long time, right? It existed before Spark, it existed before MongoDB, and so did JavaScript, right? So when you build a database product and you want to come up with a way that the users interact with your product, you have several strategies. One strategy is to say, well, there already exists languages that people use to write computer programs, like Python, like JavaScript, like C++, like Java, and so on. So what you can do is provide a library in that language, so a library in Python, a library in Java, a library in C++, that provides access to your database product. It's also called a driver, right? So we could say there's a JavaScript driver for MongoDB, there's a Python driver to MongoDB. Driver is the same name that we use also for a printer or a scanner. You basically, I mean, it's no longer the case today, but when I was young, when you added a printer, you needed to install a driver so that the computer knows how to communicate with the printer. So technically, an API does that. It's kind of a driver that tells Python or that tells JavaScript how it can speak to MongoDB or to Spark and so on. And basically, in an API, if you take, for example, the Spark API, the PySpark, it's an API because do you remember that list of transformations? Filter, flat map, map, reduce by key, and so on. In fact, these are just Python functions, right? It's just Python functions. So all is done here is to take the Python language and we just throw in a few new functions that do things against the Spark backend, right? So this is pretty much the idea of an API. But if you think there's many other APIs, who knows NumPy, Pandas, Scikit, and so on and so on. These are all other kinds of APIs in Python, right? So this is an API. It's an extension of an existing generic language, Python, Java, JavaScript, and so on, a generic language that is extended with new functions and new functionality in order to provide a way to interact with the database management system. So that's an API. A query language is something different. A query language is something completely new. SQL has nothing to do with Python or JavaScript or Java or whatever. It's a brand new language that's completely on its own. And in fact, it's so completely on its own that you can, in Jupyter Notebook, have a cell that just contains SQL, right? You have this %SQL or %% that does the magic. Then you write SQL. Typically, it's easier to interact with a database system with a language because that's less to learn. If you learn SQL, you just need to learn this select from where, group by having, order by limit of set, right? And then the predicates and so on. Then you write your SQL. It's typically easy to learn. In fact, the name SQL was originally called Structured English Query Language for exactly this reason. However, you probably experienced when you try to use PySpark that there is a higher hurdle to using PySpark. Why? Because not only do you need to learn the Spark API, but you also need to learn Python. So that's more things to learn. Another way that you see that is more cumbersome in an API is that you're going to have a lot of parentheses all over the place. When you use PySpark, you have filter, parentheses, parentheses, you have lambdas, so you have a lot of overhead in the syntax that makes it a bit more complicated to read, right? As opposed to a query language like SQL that is a bit easier for human beings to parse. It's also easier for non-technical people to learn a query language than an API. Does it make sense? Right? So this is the intuition. And basically what I'm going to do now, because on MongoDB, what I showed you is an API in JavaScript. Now I'm going to show you a full-fledged language, just like SQL, but it's capable of handling collections of trees, nested, heterogeneous, everything. Now, that language, you already know, it's called JSONic. And by popular demand in previous semesters, I gave you a few tutorials at the beginning of the semester, a little bit every week, to smoothly introduce you to it, and that should help you follow the lecture that is coming now. Who did these tutorials? Some of you, very good. If you didn't, then you can still do it, right? You can still take the tutorials and use with the Docker. Another alternative is to use the try it out page on the jsonic.org. There's a try it out, and there's a public notebook that is hosted in the cloud that you can also use. So anyway, there's plenty of ways, but don't worry, because now I'm going to introduce you to JSONic anyway. So if you did the tutorial, it's just going to make it easier. All right. So, wow, we are here. We are almost done. This is the last lecture with material, and then in 2 weeks, there will be the final lecture, but this is for fun. It's just big quiz and wrap up and so on. So we're almost there. Do you remember data independence? Is the idea that you have a language, query language, and physically it turns out to be PostgreSQL, but now you know that SQL also exists for Spark. So technically you can also use SQL on Spark, right? It also works on HBase. There's something called Hive that allows you to use SQL on HBase. It also works on Apache Spark. That's the Spark SQL. Now that would be what you could do, and well, not you, actually, the implementers of the system, you don't have to do it. You as a user write down the Spark SQL or the SQL. Internally, Spark will map it to the API of Python or Java or whatever. But what's new with the query language is that you no longer need to bother with that API. It's completely hidden. The API is still useful for implementing that, right, internally, but the end user will no longer see the API. They will just see the query language. All right. And then in the special case that it's homogeneous and normalized, you can even use, so that was the RDD API, but you can also convert it to the data frame API, right? All right. Now, with SQL, it's good, but SQL was designed for flat and homogeneous cases, and that's what we call a relational table. The problem, I mean, for machine learning, this is also what we love to have. The problem is that in the real world, data is not like that. Data is not clean. Data might be heterogeneous, nested, and so on and so on. So if you download real world data sets, it might look more like this with missing value, extra values, invalid values, nested tables, and so on. And so there is a bit of work to clean it up. The problem is that you cannot do it in SQL. And in fact, you have to do it, if you don't have a language for that, you need to do it in Python with an API and so on. That can be very complex. So now we have a language that covers this nested and heterogeneous case. I showed you the limitations of data frames. If you try to use Spark SQL, is that if you have in your data some differing types, for example, the name might sometimes be an object, sometimes be a string. The problem is that if you do have that, Spark is going to just hit it with some hammer and just force fit it into a column that is in fact a string. That is extremely difficult to manipulate with Python after that, because this is a string, these are not objects. It's very, very difficult. The same here with countries that might be strings or arrays. It's going to hit it with a hammer and get a string. Here it's a lot of nulls. This is basically pushing the burden to the end user. It's like, okay, your data is heterogeneous. I hit it with a hammer, now deal with it, right? This is the way. And if we don't use SQL, but a language that is more adequate for heterogeneous data, then it makes it easier to deal with it than with SQL. Now, we also saw that these queries can become complicated, right? I told you this can easily give me headaches, right? These lateral views and explode and so on. It's very, very difficult to handle. I think of the explode thing as some spooky action at a distance, a bit like quantum physics, because it has an effect on duplicating cells and so on. So from a querying perspective, it's difficult to comprehend. Now, another problem with SQL is that there are questions that seem simple in English, like, for example, who is the top committer for every event in GitHub. And now you need to write it in SQL. And that was by Ingo Müller. He was a head TA for the course. He wrote that in SQL. Something as simple as saying what's the top committer in every event. Well, in JSONic, this is what it is. And the reason is the data is nested. Even though you could do it in SQL, doing it in SQL is extremely costly and will cost you a lot of time. But with a language that has been invented to directly natively process trees and deal with nestedness and heterogeneity, suddenly it's much simpler, right? So this is the motivation for a language like this. Who is with me? Now we are going to go through the language. And that language will be easier to learn than the MongoDB API. It's only an API. You could implement it on top of the MongoDB API if you want it, but hopefully the user would use the language. Computer, need to move on with the slides. Thank you, too fast. Okay. Let's not let the latency of 4.0, right? But maybe one day we'll get it in the lecture. Okay, now I don't know what's going on. Is it that I need to load it again? I don't know. Maybe I'll use the keys. I think it's the battery again. Okay. We have a data set that you will have in the exercise and that we'll also use at the exam. We almost use it in every exam. Do you know if we'll use it again at this exam? I think so, right? Probably we keep using this one. It's a heterogeneous data set that comes from GitHub. It's actually just a portion of it because the data set is gigantic, but it's heterogeneous because the attributes are not always the same. 10% of the keys have mixed types. It means that sometimes it's an integer, sometimes it's a string, even though it's the same key, right? So it breaks all of the rules, right, of a relational table. You cannot use PostgreSQL with that, or SQL. Well, you could, but it would be very complicated because of this. So this is a very good use case. So the total data set, last time we checked, had 7 terabytes of data, but it keeps growing, so now it's even more. Of course, on exam day, it's not going to be that big. I think it's just a couple of megabytes or something. All right. So now we are moving on. Instead of SQL, we are putting JSONic. That is a language that can be implemented on top of Spark, HBase, Hadoop, MongoDB, whatever you want, right? So SQL, like JSONic, check 3 boxes that make them query languages as opposed to Java, Python. These are not query languages. The first thing is that it's declarative. In SQL or JSONic, you say what you want. You want to select these columns where that predicate is fulfilled. That is declarative. In Python, it's not declarative. In Python, it's do this, do that, and by the way, do this and do that, and so on. So that would be imperative. So the first thing is declarative. The second one is functional. What is meant with functional is that you have expressions in a query language that fit into each other. And it corresponds a little bit to function call in math. But the beauty of a query language is to hide the functions, because you would expect if you have a function to have parentheses all over the place. In fact, that's what happens in the APIs. But the beauty of the query language is to be carefully crafted in such a way that it looks lightweight to the user, right? It is a functional language, but it doesn't look like a functional language to the user, right? But I'll come back, you will see when we start using that, right? So it's like a Lego game, and you just learn the pieces of Lego. There's only 37 in JSONic, and then you just assemble them in any way you want. And finally, the third thing is that it's called the set-based language. The reason is that if you look at Java or Python, the values you return is one at a time. A pointer to an object, a string, and so on. But in SQL, you can return a table with 1 billion rows. In JSONic, you can return a collection with 1 trillion records, right? So this is why it's called a set-based language, because a single value can hold petabytes of data. That's extremely powerful because you implement that on top of a cluster and with very powerful physical levels. So it's a Lego game. It's really a Lego game. We have an implementation that we use for this course and for the exam that's called RumbleDB. It's made at ETH. It supports S3, HDFS, HTTP, the local file system, Azure. It can read JSON, CSV, Parquet that we saw, text can be read as well, roots, that's for the high energy physicists at CERN, libsvm for machine learning and so on. And the vision is that JSONic also can be used for the entire ecosystem, including machine learning and so on. But that I'm not getting into in this course, but just to tell you the vision. And Lakehouse is the fancy name that was dropped 3 years ago for this fully integrated system that has the database plus the machine learning in the same wood. Just to show you how many people contributed to it, this was done by you, or more exactly your predecessor. So this is a student's efforts in many different projects. And it became very mature with time and rather stable. And now I have David, who is currently writing his master's thesis with me. All right, but what is it? It's really a data calculator, right? If you have a calculator, 1 + 1 returns 2. So this you can do in JSONic. 1 + 1 will return 2. That's a JSONic query. That's also a JSONic query. That's a JSONic query. It returns a Boolean, right? So you enter 2 lower than 5, and it says true. You can put that in the Jupyter notebook. The JSONic is going to say true. But it's a fancy calculator because it can do many, many more powerful things. For example, that's typical in functional languages. You can say, please give me $i + 1, knowing that $i is 2, right? This is how you should read that. If you assume that $i is 2, then please give me $i + 1, and that returns 3. That is a let variable. Many functional languages have a let variable like that. What's cool also is that since we are talking about JSON, arrays and objects are also part of the language. You can literally copy-paste any JSON, and that is also JSONic. It's just a JSONic that returns itself. So if you put an array, it just returns the array. Put an object, it returns the object. Right. So technically, JSONic is a superset of JSON. Right? Any JSON is also JSONic that returns itself, but it's more than that. Because you can also, for example, navigate. So if you have an object and .foo, that's going to extract the one inside. Who sees that? Right? That's no longer JSON, right? Now it's JSONic. But the .foo is going to go inside and extract the one that is associated with the foo. This here, this double square bracket, is going to take the first, we start counting at 1 in JSONic. The first value of the array is 3. So you have the array 3, 4, 5, and then you're picking the first position. That's a 3, and so on. Now that's a more complex one. You have an object with a key foo associated with the array 3, 4, 5. If you say .foo, that's taking the array. 1 is extracting the first one, that's a 3, plus 3, 6. Who understands that? Right? You can also put that in a Jupyter notebook. That's going to work. All right, now what's also cool is that I told you it's set-based. It can also return billions of items like this. For example, in that case, if I have foo is an array, I say .foo. Now this square bracket after the foo is an unboxing. It's like opening a Christmas present. So you take the array, .foo gives you the array, and you crack it open. 3, 4, 5. Right. That's basically a sequence of the 3 integers. You opened the array. You can also say 1, 2, 4 is a range that outputs 1, 2, 3, and 4, a sequence of 4 integers. You have for loops that allow you to iterate, but in a functional way. So for example, you're going to return an object with $i as a key and $i times $i as the value for every value of I between 3 and 5. So you do it for 3, for 4, and for 5, and this is what you get, right? The key has to be a string, so of course the quotes will be automatically added back to make it a string. Who follows? Okay, so this is the language we have. I can even replace that with any way I want. It's a Lego game. You can put anything you'd like, anywhere you'd like in JSONic, and it just works. Then you can start reading data sets. That's why I'm going to stop here. Here you read a data set from S3. You see you can directly pass the S3 path with the bucket and the files. Can be also HDFS, can be your local file system. You pass it to JSON file. It's automatically going to parse the JSON, iterate over it, return all the values, and keys is a function, a built-in function of JSONic that extracts the keys. So this is telling you in that data set that might have petabytes of data and billions of objects, very quickly it's going to return foo and bar, telling you these are the only keys that I found in that gigantic data set. It's magic because actually there is Spark hidden behind that, but Spark is completely hidden. The only thing the user sees is JSONic. And that is thanks to all the students who managed to hide Spark behind JSONic. That's it. Thank you very much. Next week, we'll continue and end the JSONic lecture. And then in the final week of the semester, we'll celebrate together the end of the semester. I will give you an outlook. We'll talk about the exam. We'll have a big quiz like Eisgagger 100 that I like to do in every course, if you know the TV show. Thank you very much. Enjoy the exercises. And I will see you next week at 8 a.m. for the continuation in the end of the JSONic lecture. Thank you very much.